Hello. So we're going to be doing exam 2 review for college algebra. So let's start. The first problem says, find the distance between the points -1, 4, and 3, -6. Give the exact distance and an approximation to 2 decimal places. Show all work. So I'm going to do some work over here on the side. So our 2 points are -1, 4, and 3, -6. So we want to find the distance between these 2 points, right? So the distance formula states that you can find the distance of 2 points by using this formula, x2 minus x1 squared plus y2 minus y1 squared. So we simply will plug in what we know. So this x2 and this y2 we'll call these 2 points, and this x1, y1 we'll call those 2 points. So if we're trying to find the distance, trying to find the square root of x2, which is 3, minus our x1, which is -1, and we're squaring all of that, plus y2, which is our -6, minus our y1, which is 4. And we're squaring all of that. And this will get us the square root of 3 minus a -1 is 4, so it'd be 4 squared, plus -6 minus 4 would be -10 squared. So this gives us 16 plus 100, or 116. And this would be our exact answer. So now to get our approximate answer, we just plug this into the calculator and then take it to 2 decimal places, and that will give us 10.77. So this is our exact answer, and this is our approximate answer. Alrighty, next problem says, determine if the points M, P, Q form the vertices of a right triangle. Show all work. So, if you remember, a right triangle follows the Pythagorean theorem that states that a squared, or the sum of the squares of the legs, is going to equal the square of the hypotenuse. So what we do is we'll assume points M, P, and Q are these vertices, and then we're going to see if our distances from here to here, here to here, here to here, fit into here and follow this rule. So I'm going to write our points down real quick. M is -2, -3. P is 4, 1. Q is -1, 7. So I'm going to go ahead and zoom us in. So I'm going to go ahead and do a rough plot, a rough sketch of what we have going on here. So our first point, -2, -3, is somewhere here, right? So that's M. Our next point's +4, up 1, so right about here. That is point P. And our final point is -1, +7, so somewhere here. That is point Q. And the question is, this a right triangle? Obviously, my picture's not drawn to scale, so we can't tell from my picture. But what we can do is find the distance here, the distance here, and the distance here. So we'll call this distance 1, 2, and 3. And we'll solve it the same way we solved the distance up above. So distance 1 is a square root, and I'm using this exact definition up here, is the square root of our points M to Q. So our differences in x's will be -1 minus a -2. And then our differences in y's will be 7 minus a -3. Which will give us, if we plug into the calculator, and I'm going to round it to 2 decimal places. Okay, so I got 10.05 roughly. So that's a rough distance, okay? Now we'll do the same with distance 2 and distance 3. So distance 2 is a distance between, we called it Q and P. So I'm going to go ahead and do that here. We'll do the difference of the x's plus the difference in the y's, and that will give us 7.81 roughly. So now we'll do that same thing for the third distance, which is our distance between M and P. So I'll go ahead and do the difference of the 2 x's plus the difference of the 2 y's, and that will give us 7.21 roughly. All right, so now we have 3 distances, and now we just need to figure out if they fit into our a squared plus b squared equals c squared. So a and b are typically the legs, which are shorter, so I'm going to go ahead and call this a and this b, and then c is our hypotenuse, which is typically our longer leg, so c. And I'm going to go ahead and test that out here. If we did 7.81 squared plus 7.21 squared, does that equal, that's a question, 10.05 squared? So I'm going to go ahead and do this left side, and then I'll do the right side, and we'll see which one, if they are equal to each other. So on this left side, I got 112.98. Does that equal 10.05 squared? It does not. So what that means is that these 3 points do not form a right triangle. And that is our answer. Alrighty. So for number 3, it says, find the midpoint of a line with the endpoints -2, -9, and -9, 4. Show all your work. So to find the midpoint of a line, essentially the midpoint is the point smack dab in the middle of a line. So if we had a line that looks something like this, and we wanted to find that midpoint, given a point here and a point here, essentially the midpoint is like the average of this point and this point. So when you're looking at the midpoint formula, it is saying that you will take the average of your x values, and that'll give you your x midpoint, and then you're taking the average of your y values, so something like that. So given we do have 2 points, -2, -9, and -9, 4, we'll just plug into this midpoint formula and find what our midpoint is. So our midpoint will be the average of our two x's, so -2 plus a -9 over 2, right? Because there's only 2 points, so that's the average. And our y will be the average of our two y's, -9 plus 4 over 2. So that means that our midpoint is the point -11 over 2, -5 over 2. All right, moving on to the fourth problem. It says, graph the equation y equals 1/2 x plus 3 by plotting points. Show the points you're using in the table. So you could plot this by knowing that this is the slope and this is a y-intercept, but you want to plug it in by using points. So how you would go about doing that would be you draw a table. So something like this with x values and y values. And you can pick any x values you want. I'm going to pick these just because I feel like they'll look nice. Okay, so we will do our graph right here roughly. Y, and this is our x. So, okay. So if we remember, our function was y equals 1/2 x plus 3. So now what I'm going to do is I'm going to input these x's that I came up with here and put them in here and get a y value. So for the first one, if I input 1/2 times -4 plus 3, I will end up with a point. So if I were to input 1/2 -4 plus 3, I'd get y as +1. So that means our y here is 1. And then if I do that for all the other points, I'll get y is 2 for -2, y is 3 for 0, y is 4 for 2, and y is 5 for 4. So then whenever I go to graph it, if we plot some one, 2, 3, 4, 5, and then if we plot some x values, 1, 2, 3, 4, 5, and some negative x values, -1, -2, -3, -4, -5. We would get our first point, -4, -1, over 4, up 1. Our second point is -2, +2. Third point's 0, +3. Fourth point is 2, +4. And fifth point is 4, +5. So now our line looks somewhat like, somewhat like this, right? And that is what it wants. And we gave a table and we graphed our points. It does say show all work, so I will say to show every single one of your steps here. Okay. Number 5 says find x and y intercepts of the following equations. So if we remember, x intercepts occur when y is 0, and y intercepts occur when x equals 0. So I'm going to work these out separately. So I'm going to do A is y equals x minus 2, and B, I'm going to do this over here, is y equals x squared minus 16. So for this first one, if we want to find our x-intercepts, we need to set our y to 0. So if we set our y to 0, we'd get something like that. And we can move stuff around. So we get the absolute value of x is 2, which means there are two answers. X is 2 and x is negative 2. So that means that our y-intercepts not our y-intercepts, my bad. Our x-intercepts are negative 2, 0, and positive 2, 0. Now we do the same thing for our y-intercepts, but we set our x equal to 0 this time. So absolute value of 0 is 0, minus 2, we get y equals negative 2. So that means that our y-intercept, and we only have one y-intercept for this problem, will be, when our x is 0, our y is a negative 2. So we do the same thing for the other one. If we're trying to find our x-intercepts, we will set our y equal to 0, and then we'll solve for x by moving things around. And if we take the square root of that, we'll get x is both plus and negative 4. So that means that our x-intercepts for this problem are negative 4, 0, and positive 4, 0. Now, for our y-intercepts, we will plug in 0 for our x. So we will get y is equal to 0 minus 16, which is just negative 16, which means that our y-intercept is, and again, we only have one y-intercept for this problem, our y-intercept is, when our x is 0, y is negative 16. All right, so now to the next problem. It says, find x and y-intercepts of the equations negative x plus 4y equals 12. Use intercepts to graph the line. So, just like how we did for the last problem, just like how I highlighted here, sorry about that, right here, our x-intercepts happen when y is 0, and our y-intercepts happen when x is 0. So if we want to try and find what our x-intercept is, we will plug in y at 0, so we'll end up with something like negative 2x plus 4 times 0 equals 12. We get negative 2, this goes to 0, equals 12, divided by negative 2, x is negative 6. So our x-intercept is equal to negative 6, 0. And then we'll do the same thing for our y-intercept. We will plug in 0 for our x. This goes away. So we're left with 4y equals 12 divided by 4 divided by 4. Y is 3. So our y-intercept is 0, 3. And now it says we are going to use those two intercepts to graph this line. So if we have a line something like, or a graph something like this, y going up, x going that way. Our points are, and I'll go ahead and plot some little lines, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. And I'll go ahead and label these. Negative 1, negative 2, negative 4, negative 5, and negative 6. And then we'll do the same thing for our y's. 1, 2, 3, 5, and it goes down 1, 2, 3, -2, -3. So our 2 points are, our x-intercept is -6, 0. So -6, 0 is right here. And our next point is 0, +3. So something like that. So that means between those 2 points, we have a line that looks something like that. Alrighty. For the next problem, it says, is the point -2, 5 on the circle defined by x + 2 squared + y - 5 squared = 49? So the way to check if a point is on a circle, you would just plug in. So this point is an x, y point, correct? So we just plug into our x here and our y here. And then if whatever we plug in here equals our 49, then it is on the circle. If not, it's not on the circle. So let's go ahead and test that out. So you have something like, with our point here, so I'm going to go ahead and plug in this -2, 5 into our equation of the circle. So for our x and our x would be that, and then our y would be this 5 - 5 squared. Does that equal 49? Let's check the math. So this would be -2 + 2, which is 0 squared, plus 5 - 5, which is also 0 squared. So that gives us 0, which is not equal to 49, which means this point is not on our circle. All right, number 8 says, determine the center and radius of circle defined by this function. So if we remember, the formula of a circle is x minus a squared plus y minus b squared equals r squared, or our point A, B is simply the center of the circle, and our r is the radius of the circle. So those are the 2 things we're being asked for here. So we should just be able to look at this and pick out our center, which is our AB, and our radius. So from this, we know that this is our A. Not the whole thing. Our A is actually just this and just this. And our radius is actually not that. Our radius is just r. This is r squared. So from that, we should be able to see that our center is at 3, 7. And we know r squared is equal to 36, which means that our r is, now normally when you do the square root, you would get plus or minus a number, right? In this case, it does not make sense to say that r is a -6 because it is a distance, it is a radius. So we just take the positive of this. So our radius is just 6. Alrighty, our next question is asking, write an equation of the circle in standard form given that the endpoints of a diameter of the circle are those 2 points. So let's visualize this. We're given some circle, and we're trying to find our formula, which from the last problem we said should end up looking something like right? So we don't know A or B, we don't know our center, and we don't know our radius, but we do know some diameter here. And this diameter could be anywhere. It could be here, it could be here, it could be really anywhere. But let's say, just for simplicity, it's roughly right there. If we know diameter, we can technically find our radius, right? Because our diameter is 2 times our radius, which means that our radius is d divided by 2, which, what does that entail? That means that our radius is half the distance of our diameter. So what we could do is we could find the distance, the total distance our diameter covers, and then divide by 2. Another thing is, we're also being asked for what our midpoint is. That's this point, correct? Which, like we talked about earlier, the midpoint is the point directly in the middle of a line. Which also means that our radius spans from one end of the circle to that midpoint. So we can also find our midpoint, and then from our midpoint, take the distance formula from an end to the midpoint to get radius. So I'm gonna find our midpoint first, just so we can see more or less where it is. So our points are -2, 4, and 6, -2. So we try to find our midpoint here. Remember, midpoint is just the average of our x's and the average of our y's. So something like -2 plus 6 over 2, and 4 plus a -2 over 2. So our midpoint is equal to 4 over 2, which is 2, and 2 over 2, which is +1. Now, we found our midpoint. What does this midpoint also show? This midpoint also shows the center of our circle, right? So essentially, we found the center of our circle to be, we said AB, and we came up with the point 2, 1. So we have that much of so our equation looks something like this right now. But we still don't know R. So let's go ahead and find R. So I said that you could take the distance between your two endpoints and find the diameter and then divide that by 2. Or you can take from one endpoint to the midpoint and find the distance of the radius. I'm going to do the diameter route and then divide by 2. So if we find the diameter distance, that is equal to, or that is actually the square root of our 2 points, of our difference in x's plus our difference in y squared. So our x's are 6 minus a -2 squared plus -2 minus 4 squared, which means our diameter is this long. 10 units, essentially, right? So we know our radius is d divided by 2, so our radius is 10 divided by 2, which is 5. So we found our radius. So we know r is 5, so we can plug that into here. As 5 squared. So now you can keep your answer as just this, or you can rewrite it as x minus 2 squared plus y minus 1 squared equals 25. And both of these answers are correct. All right, now on to the last one. It says, write an equation of the circle in standard form given that the center is 3, 1 and a point on the circle is 6, 5. Show all work. So there's a few ways that you can approach this problem. So first of all, let's look at this as if it were plotted on a graph, right? So we have some center 3, 1, right? This is our center. And then we have some point 6, 5, somewhere here, right? And we know that that point is on our circle. So our circle looks something like this. This also shows that the distance from here to here should be our radius. So what you can do is, remember, our formula is x minus a squared plus y minus b squared equals r squared. So what you can do is plot your center and then find the distance from our center to our endpoint and find r. And that'll give us the answer. But another way that you can approach this is, if you can't visually see this, what you can do is you can plug in what you know. So you know x minus 3 plus y minus our other center point is 1 equals r squared, right? And then we're given some point, xy. And you might not be able to see that it's the distance, that the distance between those 2 points is the radius. So what you can do is you can plug in this x here and this y here. So something like 6 minus 3 squared plus 5 minus 1 squared equals r squared. And now r is the only thing you have to solve for. So let's do that real quick. This is 3 squared plus 4 squared equals r squared. This is 9 plus 16 equals r squared. 25 equals r squared. And like we stated from the last one, you wouldn't want to take the negative of this. So r is just 5. So now, if we were to rewrite this, we'd get our equation of a circle as x minus our 3 plus y minus our 1 squared equals 5 squared. Or also, like on the first, like on the one up top, and these should both be taken as correct answers. All right.
Okay, so for this first question, we want to write the equation of this circle in standard form. Now, standard form is just going to look like x minus h squared plus y minus k squared, minus k quantity squared is equal to r squared. Now to do that here, we have an x and a y squared term, but we also have an x and a y. So what we want to do here is try and complete the square to get it into this form. All right, so first I'm going to rearrange this a little bit. It's going to be x squared minus 10x plus y squared plus 4y minus 20 is equal to 0. Now, if we think about completing the square, what we are wanting to do is take a binomial or polynomial and get it into this form. Now, if we were to FOIL that out, we know that the pattern kind of looks like this. So if we have x minus b or x plus b quantity squared, it's going to look like this. We just have our x squared, our coefficient on the x is 2 times whatever this number is, and our constant term is the square of that number. So here, first, we have this 10x, negative 10x. So we can kind of think of it as negative 10 is taking the place of 2 times this number. So it's equivalent to this term. That means that we want b to be negative 5, right? So that means that this term, we want to have negative 5 squared. That's equal to 25. So what I'm going to do is I am going to take this x squared minus 10x. I'm going to add 25. I'm going to subtract 25. And I'm going to include the rest. Minus 20 is equal to 0. So here, this is the same as saying plus 0. So that is a fine thing for us to do. There's nothing illegal about that. That's perfectly okay. It's like multiplying by 2 over 2 or something like that. But what that allows us to do then is say, okay, well, this portion can be factored into that x minus 5 squared. Then combining like terms, we'll get x plus y squared plus 4y minus 20 is equal to 0. Now, doing the same process for y that we did for x, that 4y that we have is going to be taking the place of that 2 times b in this case. So what that means is it's going to look like here, if we were to do y plus b squared, that would FOIL out to y squared plus 2by plus b squared. 4y is taking this spot, which means that 2b is equal to 4, or b is 2. So what we want to end up with here is y plus 2 squared. And if b is 2, this b squared is going to be equal to 4. So kind of similar. Oh, sorry, this should be 45. Kind of similar to what we have earlier. X, here x minus 5 squared is going to stay plus y squared plus 4y. Then we're going to have a plus 4 minus 45 is equal to 0. And again, this here is the same as saying plus 0, so that's an okay thing for us to do. But that allows us, again, x minus 5 squared, to factor out all of this into y plus 2 squared. Then we have minus 49 is equal to 0, and then here we're almost done. If you remember, our circle equation from earlier should be x minus h should be x minus h squared plus y minus k squared is equal to r squared. This is fine. This is fine. Those are taken up by this and that. But what we need to do is rearrange this negative 49. You have x minus 5 squared plus y plus 2 squared is equal to 49. If we look at the equation here, we want our value to be squared. So instead of 47, we're going to write 7 squared. That makes the equation of our circle in standard form x minus 5 quantity squared plus y plus 2 quantity squared is equal to 7 squared. Perfect. Now moving on, we have another question that wants us to do something similar. So we have this, all of this right here. What I'm going to do first is say, notice that every single term here is divisible by 2. So I'm going to divide everything by 2. That will give us x squared plus y squared minus 16x plus 6y plus 45 is equal to 0. Now, just like in the previous question, what we want to do is complete the square, so I'm going to write out that form again. Squared plus 2bx plus b squared. So now, rearranging, x squared minus 16x plus y squared plus 6y plus 45, that's all equal to 0. So for this first part, x squared minus 16x, this is taking the part of 2bx, which means that b is going to be negative 8. So what we want now is that b squared term. So b squared here is going to be 64, which means that what we want to do is say x squared minus 16x plus 64. We always have the plus 1 gets included, minus 64 plus all the rest, y squared plus 6y plus 45 is equal to 0. So that lets us factor this part to x minus 8 squared. And then just kind of writing everything else and combining like terms, we have y squared plus 6y minus 19 is equal to 0. Now here, this is taking the place of 2by. That means that b is 3 and b squared is 9. So we're going to have x minus 8 squared plus y squared plus 6y plus 9 minus 9 minus 19 is equal to 0. Again, we want to use the positive one when we're factoring. So we have x minus 8 squared plus y plus 3 squared minus 28 is equal to 0. And then from there, just rearranging, you have x minus 8 squared plus y plus 3 squared is equal to 28. And since 28 is not a perfect square, we're just going to leave it like that. Now that will give us that the standard form of this circle is going to be x minus 8 squared plus y plus 3 squared is equal to 28. Now moving on to number 13, what we want to do is, or I guess what we're given are these functions, f, g, and h, and we want to evaluate these values. So first, for f of negative 3, that's going to be equal to 4 times negative 3 minus 3, just because f of x is this. That whole thing is going to be negative 12 minus 3, which is equal to negative 15. Moving on, g of negative 5 is going to be equal to this with the negative 5 instead of x. So that's going to be negative 5 squared minus 2 times negative 5 plus 7. That is going to be equal to 25 plus 10 plus 7, or 42. Next, for h of 13, that's going to be this with 13 plugged in. So that will give us square root 13 plus 3, which is the square root of 16, which is going to be 4. Then finally for d, that's going to be f of x with 4 plugged in instead of x, which will give us 4 times 4 minus 3, which is equal to 16 minus 3, which is just 13. Moving on to number 14, what we are going to do is take this function and just evaluate what these are. So first, f of t, that's just going to be equal to f of x with t plugged in. So that's going to be negative t squared plus 4 times t, which is the same as negative t squared plus 4t. That one is nice and easy, not too complicated. Moving on to the next one though, this is going to be equal to negative a plus h squared plus 4 times a plus h. Now what I'm going to do is kind of write this over here so I can FOIL it out. I have negative a plus h multiplied by a plus h plus 4 times a plus h. So this part here is going to become, first is a squared, outside is plus ah, inside is plus ah, and then last will be plus h squared. Next, we are going to multiply that 4 by the a plus h. And that'll just be 4a, that'll just be 4a plus 4h. Now, I will say, make sure you're careful with this negative here. That, to this point, has not been distributed through to this portion yet. But we're going to get there, so just bear with me. I'm going to go ahead and combine like terms inside of our parentheses. Plus 2ah. That negative is still in front. And then just taking that negative out, we will have negative a squared minus 2ah minus h squared plus 4a plus 4h. That is going to be our solution here. So I'm just going to write it over here. Negative a squared minus 2ah minus h squared plus 4a plus 4h. There you go. Perfect. Moving on to number 15. For each of these, we want to know if the function relates or defines y as a function of x. So that is going to be, can we set this up as a y equals, or does it pass the vertical line test? Here, for A, we can see that we can construct a bunch of lines. There's no point where we have one input and more than one output. So A is a function. Moving on to B, we can see, okay, well, set this up as x squared plus y, adding 3 to both sides. That gives us 7, which gives us that y is equal to 7 minus x squared. That is a y equals statement, so this is also indeed a function. Here we have, it's kind of fuzzy, but I believe it's negative 3 goes into 11, negative 6 goes into 13, and 9. So something to point out here is that for this input, we are given 2 outputs. So that would mean that at negative 6, we will have 2 points on our function, or on our curve, which means that this is not a function. So it's not going to pass a vertical line test. Now moving on to the next part, this one is a little bit more complicated, but I would say no matter how you want to rearrange this, we're never really going to end up with a statement that's just y equals, that's going to encapsulate, that's going to show the entire function or the entire curve. So this one is not a function. On to number 16, we want to use a vertical line test to determine if the relation defines y as a function of x. So again, the vertical line test is just, we want to test to make sure that over the entire interval, there will not be a value, there will not be an x value that has more than one y value. So here on A, I think it's pretty clear to see that this is not going to pass the vertical line test. That very clearly has a lot of fail points all over the curve. So this one is not a function. I'll just draw a line to kind of demonstrate that we have a point here, a point here. That's not going to work. Here on B, we can draw as many vertical lines as we want, but we are not going to see a single, we're never going to see a fail point for the vertical line test. So this one is indeed a function. And then moving on to that last one here, it looks like we're okay. And then all of a sudden at 3, or at negative 2, we're defined at these 2 points. So this one, because it fails here, is not a function. So it doesn't matter how many times we fail. If it fails at any point, that makes it not a function anymore. Next, we want to determine the x and the y intercepts of the following functions and show all of our work. So I guess before we do anything with that, let's say the x-intercept, that's going to be when y is 0. The y-intercept, that is when x is 0. So for this first one, that's what we're going to use to solve that. So right off the bat, if we want to determine the y-intercept here, you have absolute value of x minus 5, f of x So for the y-intercept, that's going to be 0. Oh, sorry. Y is equal to the absolute value of 0 minus 5. Now, absolute value of 0, that's just 0. Minus 5 is negative 5. So our y-intercept is going to be at the point 0, negative 5. The x-intercepts get a little bit trickier just because that's when y is 0 and y is, I guess, let's see. So we're going to have 0 equal to the absolute value of x minus 5. So if we add 5 on both sides, we get the absolute value of x is equal to 5. Now this is going to split off into two equations because we have the absolute value bars. That means x could be negative 5 or x could be positive 5. And both values are valid for this. So that's going to mean that our y or our x-intercepts are going to be negative 5, 0, and 5, 0. So I'm going to go ahead and write that over here. At negative 5, 0, 5, 0. Y-intercept was at 0, negative 5. Now under the next function, we're looking at g of x is equal to negative root x plus 3. So to find the x-intercept first, just to make sure I have that, it's negative root x plus 3. That's going to be at y is equal to 0. So that means that we're going to set 0 equal to negative root x plus 3. So if we add a square root of x to both sides, that means that the square root of x is equal to 3. Now to get rid of this square root, what we want to do is square both sides, which will give us that x is equal to 9. So that means that the x-intercept is at 9, 0. Now the y-intercept at x equals 0, that's just going to be y equal to negative square root of 0 plus 3. The square root of 0, that's just 0. So here we're going to have y is equal to 3. So this point will be 0, 3. Now that, I'm going to go ahead and write down. We have an x-intercept at 9, 0, and a y-intercept at 0, 3. Perfect. Now for problem 18, what we want to do is take all the functions and write the domain in interval notation. So for this first one, we're looking at x minus 3 over x plus 7. Now, the main thing we want to look at for the domain is figure out where things do not work. So for this part, x minus 3 is fine, but if we think about dividing, we cannot divide by 0. So anything over 0 is bad. So what we are going to say is, okay, well, let's check the values of x plus 7. Let's check x when x plus 7 is 0. So subtracting 7. That gives us x at a value of negative 7. So negative 7 is going to be the only point along this where our function does not work. So that gives us an interval from negative infinity to negative 7, union negative 7 to infinity. Perfect. Now on to the next problem, we're dealing with that. So we have x squared minus 5x plus 3. Now, polynomials, they don't really break anywhere. So this is going to have a domain of all real numbers, because there's nowhere where we're taking the root of a negative. There's nowhere where we're taking the log of a negative. There's nowhere where we're dividing by 0. So we are good everywhere, which gives us a domain from negative infinity to positive infinity. Awesome. Now moving on to the next one, we are going to have, we have 5 over the absolute value of x minus 3. Here we go. So we are worried about when does that equal to 0? So that's gonna, if we add 3 to both sides, we're going to have the absolute value of x is equal to 3, which means that this is going to split into negative 3 and positive 3, because no matter which of these is the case, the absolute value of it will still be positive 3. So that means these points are where our issues are. So our interval is going to be from negative infinity to negative 3, union, negative 3, positive 3, union. Erase this, make some room. 3 to infinity. Perfect. Now moving on to the last one here, we have the square root of 4 minus x. Where this is going to be bad is if we take the square root of a negative. So what we want is the inside, 4 minus x, to be greater than or equal to 0. So as long as this is the case, we're okay. Now this, we want to isolate x. We can add x to both sides. We get 4 greater than or equal to x, or x less than or equal to 4. Now this is going to serve as our domain. So anywhere that x is between one of those values, we're a-okay. That means that here, this is going to be between negative infinity and positive 4. And 4 is going to be included since we have that or equal to here. Perfect. Awesome. So now moving on to number 19, we're going to use this graph to determine these values. So first, determining f of negative 2. That's not too bad. Let's look at our graph. Go over to negative 2 in the x. Slide down, and that is at a point of negative 2. Now f of 3 is going to take a similar approach. We're going to go over to 3, go down. That is at about negative 1. On to the next one, we want to determine all x for which f of x is equal to negative 1. So this is going to take kind of like an opposite approach to what we just did. We want to look at a y value and determine all the x values that fit that. So here, we're looking at f of x being equal to negative 1. So we're going to look at y of negative 1, or at the y value of negative 1, and just kind of figure out which x values fill that. So here we intersect, here we intersect. This one is at negative 1, this one is at 3. So that will be x is equal to negative 1 and 3. Now for the next part, we have determine the values for which f of x is equal to negative 4. So just like earlier, we're going to look at the y value of negative 4, just kind of translate across, look over. And this one intersects at only one spot at negative 4. Next, we want to determine the x-intercepts. So those are going to occur when y is equal to 0. So if we look at our graph, that really happens. That is going to happen here and here. So that point, 0, 0. And then we also have this one, which is at 2, 0. Now for the y-intercept, here we only have one. That's just going to be when x is 0. So just along this line, again, that will actually be the same value as one of our x-intercepts at 0, 0. Next, we want to determine the domain of f. Excuse me. So looking at our graph, we can see, as I guess just based on what's plotted, we don't really have anything that's popping up here. It's continuous throughout. We don't have any breaks that we know of. So that will give us a domain of negative infinity to positive infinity. And then lastly, for determining the range, that is just the possible outputs of our function. So from left to right, I'm just going to say we're coming up from negative infinity, we're going up, keep going up, on and on and on, hit this maximum of 1, keep going back down, and then to the right, it's just staying at a constant number. So here, our maximum is going to be at 1. If you look at our graph, there's not really, there's not really any values that go above that. So our maximum on our on our range is just going to be 1. And then again, looking at our graph, here we're coming up from negative infinity. So that is what our range is going to be. Moving on to number 20, we want to graph the line represented by each equation. So for this one, first, I'm just going to draw our graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so here, looking at this first one, we are looking at 4x plus 2y equals 2. So I'm going to go ahead and try and isolate this y. Subtract 4x, which will give us 2y, equal to negative 4x plus 2. And then dividing everything by 2, we are going to end up with y is equal to negative 2x plus 1. That means that our y-intercept is going to happen here at 1. We have a slope of negative 2. So for every 1 that we go over, we're going to go down 2. Over 1, down 2. And that now is going to give us a line that looks like, line's going to look like this. Just like that. So here we go. That is what our line is going to kind of look like. Now on to this next one. Here we're just given y is equal to 1. So that means that no matter what x is, y is always going to be 1. So y is always going to be 1. Now onto that third one, we have negative 3x equals 12 divided by negative 3 on both sides is going to give us x equal to negative 4. So now looking at our graph, or similar to what we did earlier, that just means that no matter what y is, x is going to be that negative 4. So in our graph, that's going to look like this. And that is going to finish up part 1. So make sure to like and subscribe, hit that notification bar, and yeah, thank you.